In this clip, I'll demonstrate how to get some basic summary statistics for a particular data set. On this web page, you can find more detailed descriptions of what I'm going to do here. You may also just search for Eclair, ECLR, RStudio, and you'll eventually get to that page after navigating a little bit. Now, first thing we need to do is we need to set our working directory. You will have to adjust that to your directory and go to the directory where you have that file. And that file you can also get from the above web page. It's a file used by Wooldridge in his econometrics textbook. So we set the working directory. Let's run this and we upload the data. Now, here, as we upload the data, you'll see I already indicate that there are some entries which are just a decimal point and they are missing observations. And I tell R that it should treat these as missing observations. That's what this little option does here. So now we have our data set and we can actually look at the table of this data. It's just a big table. It looks exactly like it would look if you looked at it in Excel. So the easiest way to get a first summary statistics is with this command summary and then the name of your data frame. So let's run this. What we get here is just for each of the variables in the data frame, we get a little block of summary statistics: minimum, mean, median, maximum, first and third quartile. Now in LF, that's a dummy variable. Whether an observation is in the labor force or not, the mean is 0.5684. That means about 57% of observations are active in the labor force. On average, our respondents work 740 hours a year. A lot of them would be 0. You can see there minimum values of 0. In fact, the first quartile, so at least a quarter, do not work any hours. And so forth. For each variable you can find first summary statistics. Now, unfortunately, the programmers of R didn't think that it was important to include the standard deviation in this little summary. And of course, we know as econometricians, we want information on that. We'll get back to that later. Now, the next important sort of summary statistic, especially when you have several variables, is how the variables are correlated. So it's a very easy command. COR and then in brackets the name of your data frame. We run this. What you now get is actually a very big object. Let's make that a little bigger. And here's the beginning, and it reports all sorts of correlations. So here, for instance, the correlation between age and hours worked is very close to 0, slightly negative. So there's basically no correlation here. Now, when you look at this, you can already see the wage variable. There's a lot of NAs here. And why is that? Well, the reason for that, we can see if we go back to our little wage summary statistics, R tells us that there are 325 missing observations. Now, when you have missing observations, your statistical software, is it R or anything else, needs to decide what to do with these missing observations. And the default for the R command, correlation command, is that the correlation function says, well, I have missing observations. I can't calculate a correlation. And that's quite sensible, because you as a researcher need to think about what shall I do with these missing observations. So we will soon come back to sort of a bit more detail on different summary statistics. But before we do that, we now have to learn a couple of things. Firstly, we will learn how to deal with missing values. We encountered that problem already. And then we'll also learn how we calculate more specific summary statistics. So we don't always want this huge outputs here for all variables and all observations. We learn how to calculate summary statistics for specific variables and perhaps even specific observations. So how to deal with missing values. So let's look at that correlation. Let's say we're interested in the correlation between education and wage. So we can use that correlation command again, but rather than applying it to the entire MyData data frame as we did here, we will now apply it only to these two variables. And we do that by addressing by selecting these two variables from our data frame like this, collecting the names of these variables in that collection vector. So let's run this, but we will get nothing else. We will get basically just a cut of this larger correlation matrix and still wage NA. The correlation between education and wage is NA because they're missing values for the wage variable. Now you need to learn how to deal with this. If you have a problem like this, you should possibly find the help function for the correlation function. You should find some help, and we do that by $correlation. So once you call the help function, you can find all sorts of advice, and actually it turns out there are possibly several ways to deal with this. But for instance, there is a use argument for your function, and here there are certain options of which sort of observations you want to use, and complete ops is what we want. Okay, we want to use complete. You actually don't have to write it completely out, so you can write complete only, but you could use complete.ops as well. So in our correlation function, we need to tell our correlation function of what it should do with these missing observations. By default, it just said I can't calculate it, and if you say complete, you're basically telling R to only use those observations where it has all the observations for all variables. So let's run this, and we now find that we get a somewhat positive correlation coefficient of 0.34. Now it's very important that you learn how to use this help function, and sometimes you just need to look at the options that are available for you. So this is how we can use one way of dealing with missing values. Now let's next look at the following problem. Let's say we want stats just for a selected range of variables and not for all the variables before. Now with the correlation, we already saw how to do that. We can use our data frame, but not the entire data frame, but just specific variables. So we can do exactly the same, for instance, with the summary command. So you say we want a summary statistics from my data frame, and for these two variables, hours and husband age, for instance. So we run this, and now we get our two little summary statistics just for these variables. And here's another example for correlation. Let's say we want the correlation for education, mother education, and father education. And we get a little correlation matrix that only involves these three variables. So that's the first way of how you can get summary statistics for just a subset of variables. The second way how you can do that is to use a very useful function. It's the subset function. So what we do here first is we very clearly define a subset and save it in a new data frame. So that's what we do here. So we define a new data frame, mydata.sub0. You can give it any name you want. And what do we do here? We call the subset function, and we tell the subset function, take the data frame mydata, so the complete data frame, and then select the following variables, hours and husband age. Okay, so if you run this, you will see that you can look at your environment, and you can now see a new data frame, mydata sub0. It has 753 observations, but only two variables, and only the two which we specified, hours and husband age. So once we have this data frame, we can now apply the summary command just to the entire data frame which we just defined. Okay, and we get, of course, exactly the same as what we've achieved up here. But this can be quite useful, especially if you want to do several things with that particular subset of variables. It's just quite convenient to define it first. So for instance, we could then calculate the correlation for these variables as well. So this is how you select certain variables. What about selecting certain observations? So we have 753 observations, but perhaps we saw earlier we have a lot of observations where people don't work, and that will, for instance, show in that the number of working hours in the year is equal to 0, we can quickly look at our data set and we can find the hours variable. It's here, the second variable, and if we go to the bottom of the file, we can see there's lots of zeros here. It's the second column of data here. That's the hours variables, lots of zeros. So let's say we want to restrict our analysis to only those who actually do work. So let's use the subset command again. So we define a new data frame, mydata.sub1. Now we use the subset function. We tell the subset function, take the data frame mydata, and now what it should do is the following. We enter this term hours larger than 0. Now this is quite important what's happening here. So we'll just copy this and we'll put that into the console, and I put that in. Now let's see first. I'll press enter, but we will get an error message because it says object hours not found. If you look at your environment, there isn't anything that's called hours, but my data, it is actually in the my data frame. So if I do this, what I get is the following. I get what's called a Boolean or logical variable. Altogether we get 753, that's 753rd observation, and I get either a true or a false value in here. True if that condition is true, so if the hours for a particular observation is larger than 0, and false, that was at the end of the data set when it is not. So how does that help? Basically what's happening here now is that our subset function takes all the data in the mydata data frame, but it selects only those rows where hours is larger than 0. So if we run this command, we get a new data frame. It's this one, mydata sub1. Now we can see we only have 428 observations here. We still have all 22 variables, but only 428 observations. And that's all those for which the hours is larger than 0. So let's look at this data frame. Second column is hours, and if you go all the way down, all of them are positive. So that's very important. In here we selected a subset of rows. When you use that select option in the subset command, you select variables, and if you just put in a logical statement like this one, you select rows. And now we can calculate a correlation for the variables education and wage, say again, but only for that subset. Now we get the same result here as before, because correlation and wage is basically the missing observations we previously deleted for wage were all those where the hours were equal to 0. So that's how you use subsets of data. You can of course combine this. So for instance, subset will redefine mydata sub1, subset function, mydata data frame, only the rows with hours larger than 0 and only variables education and wage. So if I run this, we will find that now our new data frame, mydata sub1, has only 428 observations, but also only 2 variables. And again, you can now, of course, immediately onto that data frame, you can apply your correlation function. So we've now learned how we can select particular variables from our data frame and or particular rows from our data frame, particular observations. So let's continue with more summary statistics, and we'll start with categorical variables. We will now use a library called Mosaic. Now you know that to use a certain package you first have to install that. I've done that on my machine. You may have to do that first, but you should know how to install packages. But you also know when you then want to use them, you have to call the package by using this library command. So let's do that. library. Let's hope it this worked. Yeah. Okay. I had highlighted just the library and then run, and it tried to open the actual library functions, and that was a bit of a mistake. So just put your cursor into that line and press run, and you get it, or type library mosaic into the console. So the package is loaded. Now we have categorical variables, for instance kids larger than 6 years. So that tells us, that's a variable which tells us how many children larger than 6 years a particular woman in that data set has. So let me just execute that command and then we'll talk about it. So what you get here is, let me just clear the screen. You can clear the console by pressing Control L. And let me execute that command again here. So what we get here is, you can see that there are 606 observations, so that we only have women in this data set, 606 women which have no children that have age less than 6, that are younger than 6. 118 women with 1 child less than 6, 26 with 2, and 3 with 3. Altogether we have 753 women in our data set. Now this tally command just produces this sort of the table. Now how does that work? This command, the first input is the name of the variable, but it's possibly easiest to start with this. Data equals my data. You're basically telling that command which data to use. You say my data data frame. Use all the data that are in my data. So then we say which variable, and that's the kids LT6. And we precede this by this little squiggly line. I think it's possibly best to just accept that you do that at this stage. When you run regressions and produce graphs, this will reappear again and it will all make sense. But for the time being, just accept it, that it's there. So name of the data frame, name of the variable. And you could run the command just like this. This last optional input tells us margins equals true. You can look at the help function for tally. Basically what this makes sure is that we get this final column here with total numbers, okay, marginal count. So what you saw here is by default you get counts. Sometimes you want percentages, and all you need to do then, you need to add this little optional input to the end of your tally function. So let's run this, and now we can see, rather than counts, we can see percentages. 80% of women have no child younger than 6 years. And sometimes you want it in proportions, and then you use this little additional input into the tally function. So let's run this, and now you have proportions. Okay, but of course nothing else changes in terms of the real information. Now, if you have several categorical variables, you often want sort of a cross table or contingency table, and you do that with exactly the same command. And let's say we want to see a cross tabulation between how many kids greater or at least 6 years old, and that's this variable, and how many kids younger than 6 a certain woman has. And all we do is we use exactly the same command as here, but you add the second variable with this plus. It doesn't matter whether you add it before or after. So let's run this command. And what you see is now a cross tabulation. You can see we have up to 8 children. There's one woman which has 8 children which are older than 6. And then we have our variables younger than 6 here, our variable younger than 6 here, and this is just an obvious contingency table. Altogether 753 observations. And again, you could change this command to output percentages or proportions by just adding this extra bit of information to the tally function. So this is how the tally function works, and what is very, very neat about the tally function is that you can also produce very easily conditional tables. So let's say you're interested in the number of kids that are older than, or at least 6 years old, but conditional on a woman having at least 16 years of education. So that's equivalent to a postgrad degree. Otherwise, the function is exactly the same. So it's tally. We're using my data frame. We want marginal values. And let's say we are interested in proportions. So let's run this. So what you now get is, again, this table of proportions of what proportion of children have certain number of women have certain number of children. But now we get two columns, one for when this condition is true, so one for women that have at least 16 years of education, and another column for those where this condition is not true, so those women who have less than 16 years of education. And here we can see the proportions, and perhaps you can already see that women with less education tend to have more children. So it's a very easy way to get these conditional tables, and you can actually add additional variables here. You can just try that, but of course the output gets a bit more complicated then. So last, we want to go to continuous variables and summary statistics for some more summary statistics for continuous variables. So we already know that we can use the summary command. We used that before, but let's say you only want a specific statistic. Let's say you want the mean. Now, the way how we can use that mean function is very similar to that tally. Okay, we tell the mean function what data we want to use, data in the data frame my data. We want to use variable wage, and we have that squiggly line again in front, and we tell it what to do with the missing observations. Okay, na.im for remove equals true, so we want to remove the missing observations. So let's run this, and we get an average value of 4.177. Okay, so that you can now replace mean with median or max and min, or actually standard deviation. And you could get specific statistics here. Now the good people who produced the Mosaic package, which we uploaded before and which we used for tally, also got equally bugged as I did earlier by the fact that the summary function actually doesn't have any standard deviation. So they created a slightly different function called favstats, favorite stats, and which is also used basically in the same way as the mean function and the tally function here. You need to tell it which data frame to use, so data equals my data, because my data is the data frame in which we have the data, and then which variable to use here, wage. And again, we have that squiggly line. So let's run this. And what we now get is just a range of statistics, or standard statistics for the wage variable. And so here's the mean again, 4.177, but now importantly we also have the standard deviation in here, and that's just extremely nice. It's a very common statistic we're interested in. Now let's say you want to apply this to several variables, so we could just replicate this line, copy and paste, this your friend, and let's say for education we want this, we run, and then we get the statistics for education. So on average we have 12 years of education, for instance. Now if you want to apply it for a lot of variables, just replicating all these lines can be a little bit annoying, but you can do the following. This is in a way a little bit of an advanced technique. Again, you could use the subset function to create a new data frame, so mydata.sap2, and we are selecting all these variables, say for argument's sake, from our mydata data frame. So let's do that first. So we have a new data frame here, mydata sap2, that's in here. And then to apply this favstats command to basically all of these variables, you can use a function which is called df dataframe, df apply, to which data frame, my data.sap2, that's the one which we just selected, and then favstats. Okay, you're basically saying apply the function favorite stats to all elements in that data frame, and all elements means these 4. Right, so if we run this, we now get basically 4 times the output for all the 4 variables: hours, husband age, wage, and husband wage, and we got all these outputs. That's a very nice and quick way to apply this favorite stats function to all of them. But you could use different functions here as well, or you could use different data frames. So let's say we're using actually our original data frame with all the variables. If you run this now, you get a long list of these favorite statistics, basically for the favorite statistics for all the variables in our data frame. So this is as much as I wanted to cover in this clip.